Hello everyone. In this video, we are going to go through Bernoulli random variable. X Bernoulli with parameter p is the distribution where p is the success. And Bernoulli random variable is supported by 0 and 1. So we have binary outcome. We have either 0, which is failure, 1 minus p, or q, and we have success, p, where the outcome is 1. And probability that x is equal to little x is given by p to the x, 1 minus p to the 1 minus x. So we can derive expectation. Expectation for the discrete random variables by definition is the summation x times the density function. So we're going to sum all possible outcomes from 0 to 1. We have two outcomes, so we can sum it. So if the outcome is 0, then x will be here 0. So 0 times the density function, which is p to the 0, 1 minus p to the 1 minus 0. Plus, if the outcome is 1, then it's going to be 1 times p to the 1, 1 minus p to the 1 minus 1. And here we obtain 0, because 0 times everything is 0. And here we obtain p. So expectation of Bernoulli random variable is p as desired. Now we're going to derive the variance. Variance by definition is expectation of x squared minus expectation of x, the quantity squared. Here we found the expectation. We need to find expectation of x squared. And that's going to be by definition x squared times the density function. And we're going to do it for all possible outcomes. Again, we have two possible outcomes. This time we're going to use 0 squared times p to the 0, 1 minus p to the 1 minus 0. If the outcome is 1, then it's going to be 1 squared times p to the 1, 1 minus p to the 1 minus 1. Here we're going to obtain again 0, and here we're going to obtain, this is going to be 1, and this is going to be p. Now we can substitute. So variance by definition is expectation of x squared, which we found p, minus expectation of x the quantity squared, we found p, and we're going to square this quantity. So this is the variance, and if you pull out p, it's going to be 1 minus p. So this is the variance of Bernoulli random variable. And 1 minus p is the complement of p, and you can also call it q. So you can also see it in the form of p times q, which is success times failure. Now let's see the relationship between Bernoulli random variable and other discrete random variables. If the Bernoulli trials are independent, then binomial random variable is the variable that the number of success in an independent Bernoulli trials. And geometric random variable will be the distribution of the number of trials to get the first success. And negative binomial random variable is the distribution of the number of trials to get the rth success in independent Bernoulli trials. So here our keyword is that all Bernoulli trials have to be independent. Like you're tossing the coin 10 times and each trial is independent. We're going to go different examples in different videos. Thank you for watching.